Dear students, welcome and thank you for tuning in to this video with me, Dr. Al-Zube. We are continuing our discussion of the statics and dynamics, and we are starting now the dynamics part of the class, and in which we will start with the kinematics of a particle. So in this lecture and the videos of this lecture, we're going to learn how to find the kinematic quantities such as position, displacement, velocity, and accelerations. And there's a lot of variation of these quantities we're going to learn about and how to identify and calculate them. And we will find all these kinematic quantities for a particle traveling along a straight path. And that's a rectilinear motion. So you will remember from before we talked about statics, which was actually concerned with the equilibrium of a body that is either at rest or moves with a constant velocity. Here in these lectures and starting from now, we are going to consider dynamics, which deals with the accelerated motion of body. And that's a big distinction between statics and dynamics. So for an application, actually, the motion of large objects such as rockets, airplanes, cars, you name it, we have analyzed it as a particle. And there is a reason why we're doing this. The reason behind that is that from a distance, these big objects can be analyzed actually as a particle, and because we are looking at them from far away. And that is actually the reason that we are considering these big objects as particles, and it simplifies our analysis actually. If we measure the altitude of the rocket as a function of time, which is that what we were looking for from now on is looking at quantities as functions of time, we can find the velocity and acceleration using calculus, which is, you do differentiation. So if you have the position, you differentiate the position, you get the velocity. You differentiate the velocity, you get the acceleration. And on the other hand, if you have the acceleration as a function of time, you can integrate it to get the velocity, and also you can integrate the velocity if it's a function of time to get the position. And this is what we're going to do in the following videos. I know that this is probably something that you know of and used before, but we're going to look into it in a deeper and a more comprehensive view. So assuming, let's say, that we have a sports car and it travels along a straight road, can we treat the car as a particle? Yes, as we mentioned before. If we looked at it from a distance, we can assume it to be a particle, and that's to simplify our analysis. If the car accelerates at a constant rate, how can we determine the position velocity at some instant? Again, we can do integration. So if you have the acceleration, you integrate the acceleration, you get the velocity, you integrate the velocity, and you get the position. And you can substitute for the time point that you are interested in, and then you get all the values that you're looking for. So an overview before we dig into identifying the position, velocity, and acceleration, because those are the things that we are interested in. And so we'd like to look into how the structure of our, the big picture of our analysis look like. So we started with mechanics, and we said that it's a study of how bodies react to forces acting on them, and we have two parts or two categories or fields or subfields of mechanics. The first one is statics, which is the study of bodies in equilibrium. And we spend a lot of time talking about all the concepts related to statics and equilibrium and forces. And the other part or subdiscipline is dynamics. And it has two categories. The first category is kinematics, and the second one is kinetics. Kinematics concerned with the geometric aspect of motion, let's say velocities, acceleration, and position. And how can we plot them as a function of time? How can we find the values at a specific point of time? And the second part is kinetics, which is concerned with the forces causing the motion, and it relates to power, work, energy, and we're going to discuss both of them in the following lectures and videos. After this introduction, we will start our discussion about how can we treat first of all we need to define position, displacement, velocities, and accelerations, and then we're going to utilize our knowledge in solving kinematics problems. So we'll focus now on the first part of dynamics, which is kinematics, and that's what's going to happen in the following video. Thank you for watching. Until the next video. Bye.